Hey, hello everyone. My name is Huang Chong. I am a fifth-year PhD candidate from Rutgers University, and I'm very happy to present my research here, artificial intelligence in auditing, or smarter with Graph Retrieval Augmented Generation and large language models. So compared to the research before that, I will also mention my co-author is Chuanhong Han from New Jersey Institute of Technology and Chen Zhang from New York University. And a quick introduction of this research. Well, why we want to do this? Our motivation is that we find large language model lack precision of retrieving multiple documents critically in auditing process. So you may notice that you can upload multiple documents in large language model like ChatGPT. However, if you upload 10 documents at once, or you have one document has 100 pages, the machine attention is limited and it will ignore a lot of information in those documents. Our solution provided here is we use AI agents powered by large language model and retrieval augmented generation to bring the significant improvements. And now our AI agent can perform complex tasks in integrated firm-specific knowledge and reduce manual interval. In this goal, for the AI agent we built here in this research, we built an AI agent chatbot to help document retrieval, comparison, and summarization in the auditing work. Why we have this goal? This is because when we communicate with the auditing companies, they complain that all the new auditors coming to their firm, it's hard for them to know what's inside maybe hundreds of documents, internal documents. And the senior auditors have to spend a long time to train the new auditors, which is time spending, but they are just repeating the same stuff once and once. So we want to build a chatbot for the documents information retrieval. And our research approach is design science research based on the preferred 6-stage ESR process. And just another quick review of what's the difference between LLMs and AI agents. Large language model is still language model, which is based on neural network of natural language processing. But AI agent is a sequential reasoning where we focus on the workflow, as mentioned by the previous presenters. And the architecture of large language model is word embedding and transformer architectures. Our AI agents use large language model as a base layer, then we can connect it with external tools and design a specific workflow for specific tasks. And action and capability, the large limitation of large language model, as I just mentioned, one is it has limited attention to the documents. Another is it doesn't perform well outside their knowledge base, because large language model is pre-trained with a lot of documents, and it has a pre-trained knowledge base. If the user wants to use their own private knowledge base, large language model may not work in that case. Also, large language model as a language model generate random text leads to AI hallucination. When we design AI agents, we use executive external tools. That means our AI agent can directly acquire the private database from the users, from the client, and use web search if it's necessary. We also activate the tools to provide more specific and more accurate response in our chatbot to reduce the AI hallucination. That is, in our chatbot, when you ask the documents or accountant not appear in the private knowledge, the AI agent just told you, no, internally, we don't have this kind of documents. If you want general knowledge, we can provide to you. And a common application of large language model is language comparison and text generation. And AI agent is more about conversation between machine and user, chatting with documents, which is RAG and recommender system. Here's the data we use to build this chatbot. We have more than 160 auditing procedure documents from a US auditing firm specializing in IPOs. And their new auditors follow those procedure documents to perform their assigned tasks. All the documents type Microsoft Word or Microsoft Excel. Here's screenshots of our data. This one here is Excel file, and this one here is a Word file. That's what's our data look like. For information retrieval, we use Graph Retrieval. What we use is we first do the text extraction of all the documents, then we chunk them into the small pieces. Then we do element extraction, that is somehow like we get the keywords from each small chunks by using large language model. Then we do the community detection, community summary. It's somehow like clustering. After that, we cut the unfrequent relationship between the elements. After all of this, we get a graph rag like this, the map. I just randomly zoom in one of these nodes. So in the picture, you can see we have a lot of nodes, and in each node we have a keyword, and we have the lines between the rows, and they have different colors. If they are in a different color, that means they are in the nodes are in the same community. Let's take a further step in here. For example, assertions here is in the same cluster with inventory observation and in the same cluster with control risk assessment. However, since this line between assertion and inventory observation is shorter than the line here, that means assertion is more closely related to inventory observation compared to control of assessments. And I click every node, we can have the detail of the nodes, the community number, which clusters is it, which community is it, how many nodes are connected to these elements, and the description. The description is generated by large language model based on the documents we provided to the large language model, not based on the general informations. What we are now working on is we're trying to track graph rag back to the original file. So what happened is the graph rag is on the element level. We want to find the relationship on the entity level. We want to find the relationship between the documents, how the documents are related to each other, which documents are more closely compared to the others. Let's see why we need that. Because as I mentioned, we want to have the information retrieval chatbot, and we'll build a workflow like this. In our workflow, we first have a question classifier to classify what kind of questions the user is asked. If they want to generate the information directly from documents, it goes this way, and then we ask the question classifier again. If the user is asking more general questions, not specific one document, it goes this way. We inquire our graph rag to find the map. So it's a little bit hard to understand. Let me just show you the outputs. For example, we have the function like summary function. We tell the chatbot what's the name of a document, and the chatbot can find the name of the document and inquire what's the content of that document and summarize it like this. We also have a function like detailed information retrieval. This table is from our original data, how to calculate planning materialities. And now we ask our chatbot, we have a total asset of this specific number. Please use table 1 to calculate. And from 160 documents, our chatbot precisely find document one and find the threshold of that specific number, follow the formula to calculate the planning materiality. And since we are asking another question, let me know if any other methods can be used here. Our chatbot also provides other methods, which is embedded in the other documents other than table one. And we have a planning function. I just gave our chatbot a scenario. Says I want to audit the warehouse of 3M Corporation. In this case, in what step should I follow? What are the documents I should look at? And chatbot said you should follow this kind of things. There are following information just because of the limited space. I didn't put the screenshot here. And our chatbot also provided the specific documents the auditors should look at. So the new auditors can get familiar with the whole auditing procedures pretty quickly without the senior auditors assist. The evaluation of our research, what we want to do is use multi-agent method. We want to use AI plus human cooperation. The rationale is we want to combine AI and expert judgment to enhance the evaluation accuracy. The process, how do we do it? We first ask large language model to generate the initial gradient list to the outline evaluation criteria, then ask experts to review and adjust the evaluation criteria. Then we ask AI agent again to do the AI-driven scoring and finalize the gradient list to assist and score the outputs of both large language model and AI agents. Current stage, we've already contacted experts internally from the data provider and externally from some other audit companies. They've agreed to review the AI-generated gradient list. And we are now adjusting the algorithm in the information retrieval to have a better performance. Let me just show you very quick what the chatbot is look like. I've already put the question here, and I click go. I hope it works. Now you can see what I'm asking is about one specific documents, and the chat will just answer the questions and extract the information from that documents and summarize it. And it also provides some related questions. Let's say what is table 100? There's no such table. Then our chatbot will directly say, I don't have any information regarding table 100, just to avoid AI utilization. Okay, thank you. This is the end of my presentation. If you have any questions or comments, please contact me. This is my email.